Hello, we're back at it. My last video cut off because I ran out of storage on my phone, so I had to buy more storage. So I make the big bucks, so we're good. What we're doing now is we're gonna do another example of what we just did in the previous video in part one. So what I'm gonna do is I'm gonna start plugging numbers in and see what works. So I like to always do -2, -1, 0, 1, 2, but it's not gonna work for this equation. So I'm gonna switch it up a little bit. I'm gonna go -1, 0, 1, 2, 3. I'll switch it up to those points. The reason why this method won't always work is because you're not going to get pretty numbers. So I'm going to start plugging stuff in. So I'm always going to have my basis equation. My base equation. And there's always going to be, we're trying to find the y if we know the x. Because the y is called your dependent variable. It depends on whatever your x is. Now I'm going to plug in my numbers. I'm going to plug in -1. When I plug -1 in here, this right here gives me +2/3 plus 4. Or we can just call that 4 2/3. That's not really pretty, but let's move on to the next number. Let's move on to the next one. Now I'm going to do another one. I'm going to plug in 0. Let's plug in 0. 0 times this gets you 0, so this is just 0 plus 4, which is 4. And then I'm going to do my next one. And a calculator knows how to do this. You guys know how to do it yourself and know how to multiply, but I want to focus on why this method doesn't really work. Let's plug in 1. You'll get -2/3 plus 4, which would get you 3 1/3. And then I can plug in 2. And I know it looks like I'm erasing a lot. It's because I am. If I plug in 2, you get this right here gets you -4/3 plus 4, which gets you down to 2 2/3. And lastly, let's erase this. Lastly, let's plug in 3. This gets you -2 plus 4 will get you 2. As we can see, every one we change here, we lose 2/3 here. But let's try to graph those. Well, at -1, it is 4 2/3. 1, 2, 3, 4 2/3. It's like there-ish. And then when at 0, it's 4. At 1, it's 3 1/3. There-ish. At 2, it's 2 2/3. There-ish. And at 3, it's there. Now, if we look at this line, first off, see, I had to guess. I had to guess where all my spots were. Because you can't really get a clear understanding and you can't physically draw it well when it comes to 2/3, 1/3, 1/2, all that ugly stuff. So doing it this way, yes, it works. If you plug it in, it takes some plugging, it takes some chugging. Like I've only been doing this problem for 3 minutes and I've just got to this point. Now, why don't we just take this and let's move it down to the next problem. Let's try it the other way. I moved it down to my blue equation. Look how I was already ready. And my equation before was y equals -2/3 x minus plus 4, right? Now, why don't we do it the other way? The other way says, find your slope. My slope is -2/3. Now, your -2 is your y. Does that mean we're going to go up 2 or down 2? We're going to go down 2. And that 3 is our x. And since it's positive, we're going to go right. That being said, we still need to know where to start. And where do we start? We start with our b. Our b equals 4. Now, our b being our y-intercept means we're going to start at the y-axis, and we're going to go. We're going to start on the y-axis, and we're going to go to 4. That is +4 up there. Now, our slope is -2/3. So I'm going to go down 2/3, down 2/3, down 2/3. And see how that's much cleaner? It hits exactly on cross points, and it's much cleaner. And if I draw my line, my black line through it, boom, 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 boom. That is a much cleaner line, and I just did that in 1 minute. In 1 minute compared to 3 minutes, just because I'm using my slope-intercept form to reach it much faster. And this is much cleaner too. We're not messing with I didn't mess anything up. Oh, back. Cool. Right? They're the exact same line. But one gives us a better idea of where it's heading. I know that's kind of sloppy, but still. One's giving us a better idea of where it's heading. It's a lot less work, right? This, on the bottom, is a lot less work. So I'm going to put one more example on the board. We're not going to even do the top step because I feel it's obnoxious. We're only going to do the bottom step. And let's erase this. Let's zoom back in. That way we get a better, clear understanding. Whoop, too zoomed in. Right there. Cool. So let me get my chart down. Cool. And let's let our equation be y equals -4 x plus 1. So first thing I'm going to do is I'm going to decipher what I know. This is my slope. My m is -4. Now I like when slope is in the form of a fraction, so I'm going to call it -4 over 1, and that gives us a clear understanding of where we got to head. And then this is our b. This is where I'm starting. So my b equals 1. Now, do I start over 1 or up 1? Hopefully you guys said up 1, because that is our b. And then we move from there. Our slope says we got to go down 4, right 1. Down 4, right 1. Down 4, right 1. I like when we do 5. I like 5 points. We can't do 5 down 4, right 1. Well, we technically can, but it's kind of stuck there. But the other way we can do this is that there's another, put the b down here. If slope goes one way consistently, it also goes the other way consistently. So other than going down to the right, we can flip them both and it'll still be the same thing. So what's the opposite of going down to the right? Up to the left. So let's just test that theory. If I started at this green point and I went up 4, left 1, am I still on a green dot? Yep. Up 4, left 1. It always does that. That's so annoying. And it disappeared. Hopefully you guys are paying attention. I gotta reset that soon. So, boy, that's annoying. I will see you guys later. Bye.